Every breath you take may contain the remnants of a star that died billions of years ago. That's right, every single day, hundreds of tons of cosmic dust fall onto Earth. These particles are not as harmless as you might think. They are survivors from the dawn of the universe. Some grains are older than Earth itself, older even than the Sun. But here's the chilling truth. These dust grains may also carry traces of extraterrestrial life, from organic molecules to water, and even microscopic diamonds forged in the hearts of ancient stars. If life on Earth truly began with cosmic dust, then how many other worlds out there might also be seeded by the same mysterious particles? The answer could change everything you thought you knew about the universe. What if the secrets of the entire universe, from its very beginning to the origins of life itself, were hidden in something smaller than a grain of sand? For billions of years, the universe has been filled with a silent rain of particles, ancient cosmic messengers drifting across space and time. They are so small that you could hold thousands in the palm of your hand. And yet inside each one is a record, a memory, a whisper from the dawn of existence. This is cosmic dust. Forget myths, forget prophecies, forget the tales passed down by civilizations. The real record of creation is not written in books or carved in stone. It has been preserved in dust, dust forged in the violent hearts of stars, dust expelled in the death throes of supernovae, dust that predates even the birth of our sun. We are about to uncover how these microscopic fragments carry within them the blueprint of the universe. Evidence so profound it reshapes not only how we see the cosmos, but how we see ourselves. Are you ready to journey into a realm where the smallest particles carry the largest truths? Imagine this. Floating through the vast emptiness of space, hidden among the glow of galaxies and the shadow of planets, are tiny time capsules. Each one has been adrift for billions of years. They have survived the collapse of ancient stars, the birth of solar systems, and the long, cold journey across interstellar space. These are grains of cosmic dust, invisible witnesses to the history of everything. But what exactly is cosmic dust? On the surface, it sounds simple. Dust in space. But cosmic dust is nothing like the household dust you wipe off your shelves. These are minuscule particles, often less than a micron in size, smaller than a human hair, smaller even than the pollen that drifts in spring air. They are fragments of minerals, silicates, carbon, and even exotic compounds forged in conditions far beyond anything Earth has ever known. Most of this dust comes from stars. When a star like our Sun reaches the end of its life, it expels enormous clouds of gas and matter into space. Some stars die quietly, shedding their outer layers like a snake's skin. Others die violently, in supernova explosions that hurl matter across the galaxy at unimaginable speeds. In both cases, tiny solid particles condense out of the cooling gas, and thus, cosmic dust is born. Other dust comes from even earlier times. Presolar grains, particles that predate the sun itself, were created in stars that lived and died long before our solar system formed. That means some grains of dust drifting in space today are older than our sun, older than the planets, older than Earth itself. They are direct messengers from a cosmic past that no telescope or photograph could ever capture. And cosmic dust is everywhere. Though invisible to the naked eye, it permeates the universe. Entire nebulae glow with its presence. Dark clouds blot out starlight because of it, and it rains down constantly on our own planet. Every day, Earth collects more than 100 tons of interplanetary dust particles, falling silently into our atmosphere, landing on mountaintops, ice sheets, and even city rooftops. At this very moment, a tiny fragment of ancient cosmic dust might be sitting unnoticed on your windowsill. To astronomers, these tiny particles are more than just floating debris. They are a cosmic archive. Each grain is like a microchip etched with the memory of the universe, a sample of distant stars, alien chemistry, and processes that shape the galaxies. If we can learn to read them, cosmic dust becomes a book of creation written in particles instead of words. But there's a problem. While cosmic dust is abundant, it is also elusive. These particles are fragile, easily destroyed, and incredibly difficult to study. They are scattered across space, hidden among billions of stars, and when they fall to Earth, they are mixed with ordinary terrestrial dust. To unlock their secrets, scientists have had to become cosmic detectives, developing ingenious ways to track, capture, and analyze them. And so, our story moves from the invisible void of interstellar space to the laboratories and expeditions on Earth where cosmic dust has been hunted down, grain by grain, and its secrets painstakingly revealed. Imagine trying to capture a speck of dust smaller than a human hair, drifting hundreds of kilometers above your head in the cold, dark void of space. How could humanity ever achieve such a feat? Cosmic dust is scattered everywhere, but its minuteness and fragility make collecting it an enormous challenge. If we want to listen to the whispers these stardust messengers carry, we must first find a way to catch them without destroying them. One of the first strategies was to hunt cosmic dust directly in Earth's atmosphere. Scientists used high-altitude aircraft to gather these particles before they fall to the ground and mix with ordinary dust. On the wings of these aircraft, special collectors coated with silicone oil or sticky materials were installed to trap each extraterrestrial particle. When the planes landed, scientists brought back the collectors. Under a microscope, tiny specks appeared, each one a fragment of the universe, freshly fallen onto our planet after a journey of billions of years. Another method is to search for cosmic dust in the purest places on Earth, where terrestrial contamination is minimal, Antarctica. Across its vast frozen deserts, any dust found is almost certainly extraterrestrial in origin. Scientists drill deep into the ice, retrieving pristine ice cores, then analyze the microscopic grains trapped inside. There, cosmic dust particles are preserved almost perfectly, as if frozen in time the moment they touched Earth. But perhaps the most extraordinary chapter in this hunt for cosmic dust was NASA's Stardust mission. Launched in 1999, Stardust had a bold goal: to fly through the tail of Comet Wild 2 and collect cometary dust directly. To achieve this, engineers designed a special, catcher's mitt, called aerogel, a transparent material lighter than smoke but stronger than glass. When comet dust particles slammed into the aerogel at tens of kilometers per second, they were slowed and laboratories. Under electron microscopes, each particle appeared as a miniature world, filled with crystals, minerals, and complex structures. To uncover their composition, researchers turned to cutting-edge tools, scanning electron microscopy, SEM, to reveal structures at the nanoscale, mass spectrometry, to identify atoms and determine whether the grains contained oxygen, carbon, silicates, or even organic molecules, ion microscopy, to create detailed chemical maps inside each speck. Each grain of cosmic dust is like a microscopic puzzle, and scientists are the detectives, decoding the story that the universe etched within it. The results of this painstaking hunt and analysis are astonishing. Every dust grain is not just a random speck of matter but a chapter in the cosmic book. Some grains recount the deaths of stars billions of years ago. Others hold signs of water or even organic compounds, clues to the origins of life itself. And this is only the beginning. In the next part of our journey, we'll explore the profound messages hidden in cosmic dust, the secrets it reveals about the birth of stars, the formation of planets, and even the story of us. If cosmic dust are the silent witnesses of the universe, then what are they trying to tell us? What secrets have they carried across billions of years and trillions of miles of space? Once collected and analyzed, these tiny grains of stardust begin to reveal messages that reach back to the very dawn of time. The first revelation comes from the elemental composition of cosmic dust. By breaking down their chemical signatures, scientists can trace where these particles came from and how they were formed. Within a single grain of dust, you might find silicates, carbon, iron, and even rare isotopes, elements forged in the fiery hearts of stars. This tells us something profound. Cosmic dust is living proof of stellar nucleosynthesis, the process by which stars act as cosmic furnaces, fusing lighter elements into heavier ones. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen, and so on, until the most massive stars create iron before collapsing in violent death. When those stars die, they scatter these newly forged elements into space as dust. That means every grain we examine carries the memory of a star's life cycle. Studying dust is like studying the handwriting of stars, the elemental signatures they leave behind for future civilizations to read. Among the most precious discoveries in cosmic dust are presolar grains. These are particles that predate our sun, born in stars that died billions of years ago. Imagine holding a speck of dust that is older than the entire solar system, older than Earth, older than every planet, older than every living thing that has ever walked this planet. Presolar grains are like fossils of the stars. They contain isotopic ratios that don't match anything in our solar system, proving they came from other stars long gone. Each one is a postcard from a stellar ancestor, whispering across eons, "I existed before you, and I helped create the materials that made you possible." These grains provide direct, physical evidence of the stars that lived and died before our sun was born. It's like having fragments of ancient civilizations that no longer exist, except on a cosmic scale. Cosmic dust also tells us about the birth of planets, including Earth itself. Billions of years ago, when the solar system was still a swirling disk of gas and dust, these tiny particles began to collide and stick together. Over millions of years, they formed pebbles, rocks, and eventually the cores of planets. In other words, without cosmic dust, there would be no Earth, no Moon, no Mars, no oceans, no mountains, no life. Dust was the seed material of planets, the raw ingredient of worlds. By analyzing cosmic dust from comets and asteroids, scientists can reconstruct this process, tracing how the raw dust of interstellar space slowly built up into planets. Every grain is like a puzzle piece in the grand design of creation, showing us how lifeless particles became the foundation of habitable worlds. Some cosmic dust even carries isotopic fingerprints that trace back to the earliest times of the universe, shortly after the Big Bang. In their ratios of hydrogen to deuterium, or carbon to nitrogen, lie echoes of the chemical conditions that existed when the first stars ignited. This makes cosmic dust not just a messenger from stars, but a messenger from the infancy of the cosmos itself. Each grain is like a diary entry from the universe's childhood, a record of the forces that sculpted galaxies, stars, and eventually the cradle of life. So when we look at cosmic dust, we aren't just studying tiny specks of matter. We're reading history books written in atoms. We're listening to voices from stars that lived and died before our world even existed. We're piecing together the story of how dust became planets, and how planets became homes for life. It's humbling to realize that the answers to some of the biggest questions, where did we come from? How did life begin? What is our place in the universe? Can be found not in grand monuments or ancient texts, but in particles smaller than a grain of sand. And yet, the story doesn't end there. In fact, the closer we look at cosmic dust, the more extraordinary the discoveries become. Some grains carry treasures unimaginable, microscopic diamonds formed in the hearts of ancient stars, and even hints of water and organic molecules that could have seeded life on Earth. This is where the mystery deepens. This is where cosmic dust begins to blur the line between lifeless matter and the spark of existence itself. If cosmic dust has told us the story of the life and death of stars, some grains carry even more astonishing surprises, hidden treasures in the microscopic world, revealing a direct connection to the origins of life itself. Among the most breathtaking discoveries are microscopic diamonds found within cosmic dust. They are so small that only an electron microscope can reveal them, each one measuring just a fraction of a millimeter. But their value lies not in their size, but in their origin. These Stardust diamonds, were forged under unimaginable pressure and heat in the cores of massive stars. When those stars died, they expelled the diamonds into space, scattering them across the galaxy. That means when you look at one of these cosmic diamonds, you are gazing at a fragment that once lay deep within the heart of a long-dead star. It is a glittering witness to the violent creativity of the universe. But diamonds are not the only treasure. Cosmic dust has also delivered something even more essential: water. In many dust grains collected from comets and asteroids, scientists have discovered water molecules locked within their crystalline structures. This leads to a remarkable hypothesis. Earth's oceans may have been seeded by ancient cosmic dust and comets. In the early days of our planet, impacts from comets and meteorites could have brought vast amounts of water, eventually filling Earth's basins and forming the seas that cradle life today. If true, then every drop of water you drink may once have been carried across interstellar space, riding within a grain of cosmic dust billions of years ago. Even more astonishing, some cosmic dust grains collected from comets contain complex organic compounds, the very building blocks of life, such as amino acids. These molecules may have acted as the seeds that jump-started biology on the early Earth. This raises a profound and unsettling question. Did life begin with cosmic dust? If dust delivered both water and organic molecules to our planet, then perhaps the entire story of life is a gift from these microscopic travelers. The answer is not yet certain, but growing evidence is pushing scientists closer to this possibility. And this is just the beginning. Future space missions are being designed to collect even more dust, with greater precision than ever before. NASA, ESA, and other space agencies are preparing probes capable of capturing samples from comets, asteroids, and even from beyond the solar system itself. Emerging technologies, atomic force microscopes, advanced laser spectroscopy, promise to open a golden era of cosmic dust research. Each new grain returned to Earth may hold secrets we have never imagined. Secrets that could rewrite our understanding of the origins of life and the history of the cosmos. From diamonds forged in stellar hearts to the water and organic molecules that may have seeded life, cosmic dust is no longer just inert matter. It is a bridge between the infinite universe and our very existence. We are beginning to see that within each tiny speck lies the answer to humanity's greatest question. Where do we come from? For billions of years, cosmic dust has drifted silently through the universe, carrying stories of stars, planets, water, and even the seeds of life. But these grains are not just relics of ancient history. They are part of us. Every atom in your body, the carbon in your cells, the oxygen you breathe, the iron in your blood, was forged in the core of a star. When those stars died, they scattered their elements as dust, which eventually coalesced into planets, oceans, and life. That means when you look at cosmic dust under a microscope, you're not just looking at something foreign. You're looking at your origins. You are literally made of the same material as the stars. We are stardust, contemplating itself. Cosmic dust is more than science. It's a reminder of connection. Each new discovery, diamonds from dying stars, water molecules that may have seeded Earth, organic compounds that hint at life, brings us closer to understanding not just the universe, but ourselves. And yet, the story is far from complete. Missions are still being planned, laboratories are refining their techniques, and the universe is still showering us with dust every single day. Each grain holds a clue to the past and a key to the future. In a world often consumed by noise and chaos, cosmic dust reminds us of perspective. It tells us that we are part of something vast, ancient, and beautiful, that our lives are threads woven into a cosmic tapestry billions of years in the making. It challenges us to look beyond our daily struggles and ask bigger questions. Where did we come from? Where are we going? Are we alone? The answers may not be written in stone or scripture, but in dust, drifting through the stars, waiting for us to listen. So, the next time you look up at the night sky, remember, you are not separate from it. You are connected to it. Every star, every galaxy, every grain of dust is part of your story. Sparkles, and here's our challenge to you. Keep exploring. Keep questioning. Stay curious, because the more we uncover about cosmic dust, the more we uncover about ourselves. Right finger if this journey through the secrets of ancient cosmic dust inspired you. Make sure to like this video, subscribe to the channel, and hit the notification bell so you never miss a chance to explore the mysteries of history and the cosmos with us. Milky Way, after all, the story of the universe isn't finished, and together, we can illuminate its secrets.